NEC Article 810.20 addresses surge protective devices, also known as SPD, at building service entrances. However, its direct applicability to standalone antenna systems, specifically those that don't integrate with the home's electrical wiring, is less clear. In this specific instance, the exterior antenna is not grounded, and this introduces a lightning strike risk. Counterintuitively, introducing a ground, be it through the lead-in conductor or a metal shield, might make the system a more attractive target for lightning. The manufacturer's perspective is that grounding the lead-in conductor or creating a grounding path could compromise signal performance and impact FCC and IC compliance. They specifically advocate for the use of a ground fault circuit interrupter, or GFCI, outlet to guard against shorts and lightning-related surges. Determining if the NEC mandates grounding for the lead-in conductor in this context isn't straightforward. The manufacturer's stance against grounding is valid given the safety and performance implications. When approaching this situation, firstly, prioritize the use of a GFCI outlet for the amplifier, adhering to the manufacturer's guidance. Secondly, strictly follow the manufacturer's installation instructions. Thirdly, conduct regular inspections of the exterior antenna and the lead-in conductor, looking for signs of damage or past lightning strikes. Should lightning strike the system, immediately disconnect the amplifier from its power source and seek guidance from the manufacturer. Understanding these steps and the code considerations can lead to a safer installation. Let's delve deeper into each of these aspects. The NEC, or National Electrical Code, serves as a foundational standard for electrical safety in the United States. Article 810 specifically addresses radio and television equipment, while Article 810.20 mandates surge protection at service entrances. The key consideration here is whether the cellular amplifier system constitutes an integral part of the building's electrical system. Since the amplifier operates independently with its own 120 volts alternating current to 12 volts direct current power supply and doesn't directly interface with the building's wiring, its inclusion under Article 810.20 is debatable. Now consider the perspective on lightning protection. The absence of grounding on the exterior antenna does present a risk. Grounding aims to provide a low impedance path for lightning current to dissipate into the earth, thus protecting equipment and structures. However, an improperly implemented ground can inadvertently attract lightning. The concern is that introducing a grounding path where none existed before could increase the likelihood of a strike to the antenna system. The manufacturer's recommendations are pivotal. They explicitly advise against grounding the lead-in conductor due to potential signal degradation and compliance concerns with FCC and IC regulations. These regulations govern electromagnetic interference, or ME, and radio frequency, or RF, emissions. Introducing an unintended ground could alter the amplifier's radiation pattern, leading to non-compliance. The manufacturer's suggestion to use a GFCI outlet is intended to provide a degree of protection against short circuits and surge events on the power supply side. A GFCI outlet detects imbalances in current flow, indicating a leakage to ground, and quickly interrupts the circuit. This can mitigate damage from some types of electrical surges or faults. Given these factors, a definitive answer on whether the NEC requires grounding in this specific setup isn't readily available. Local electrical inspectors have the ultimate authority in interpreting and enforcing the NEC, and their opinions can vary based on local interpretations and amendments. Therefore, let's revisit the recommended actions more comprehensively. Firstly, utilizing a GFCI outlet is a prudent measure. It offers protection against ground faults and some surge events. Ensure the outlet is properly installed and tested. Secondly, meticulously adhere to the manufacturer's installation guidelines. This includes proper placement of the antennas, cable routing, and any specific instructions regarding surge protection. Thirdly, regular inspections are essential. Periodically examine the antenna, the lead-in cable, and the amplifier for any signs of damage, corrosion, or indications of a prior lightning strike. Look for burn marks, melted components, or cable insulation damage. Finally, in the event of a suspected lightning strike, immediately disconnect the amplifier from the power source. Do not attempt to operate the amplifier until it has been thoroughly inspected by a qualified technician. Contact the manufacturer for specific troubleshooting advice or repair procedures. To further understand the role of grounding, consider its different types. Equipment grounding connects non-current carrying metal parts of an electrical system to ground, providing a path for fault current to flow back to the source, tripping a circuit breaker or blowing a fuse. This is distinct from system grounding, which involves grounding one of the current carrying conductors of the electrical system, like the neutral conductor in a typical 120 volts or 240 volts system. In the case of the cellular amplifier, we're primarily concerned with equipment grounding, specifically whether to ground the antenna system. Surge protection devices, or SPDs, come in various forms. They are designed to divert transient voltage surges away from sensitive equipment. SPD can be installed at the service entrance, at branch panels, or at individual equipment locations. In this scenario, a GFCI outlet offers a basic level of surge protection. However, for comprehensive surge protection, consider installing a dedicated surge protector at the service entrance or at the branch circuit panel serving the amplifier. Let's examine the potential consequences of a lightning strike. A direct lightning strike can inject thousands of amps of current into the antenna system. This can cause catastrophic damage to the amplifier, the power supply, and connected equipment. Even a nearby lightning strike can induce voltage surges on the power lines, which can damage the amplifier's internal components. In addition to GFCI outlets and surge protectors, other mitigation measures can be considered. Shielded cables can help reduce electromagnetic interference and provide a degree of protection against induced surges. Proper bonding and grounding of metallic components can minimize voltage differences and reduce the risk of arcing. When evaluating grounding options, consult with a qualified electrical contractor or a lightning protection specialist. They can assess the specific site conditions and recommend appropriate grounding and surge protection solutions. They can also advise on local code requirements and best practices. It's crucial to emphasize that electrical work can be dangerous. Always de-energize circuits before working on electrical equipment. Wear appropriate personal protective equipment, or PPE, such as insulated gloves and safety glasses. If you are not qualified to perform electrical work, hire a licensed electrician. Remember, the absence of a mandatory grounding requirement doesn't negate the need for safety precautions. Implementing a combination of GFCI protection, surge suppression, careful installation practices, and regular inspections can significantly reduce the risk of damage from electrical faults and lightning strikes. To summarize the key points. Firstly, NEC Article 810.20 mandates surge protection at service entrances, but its applicability to standalone antenna systems is debatable. Secondly, grounding the antenna system may increase the likelihood of a lightning strike. Thirdly, the manufacturer recommends against grounding due to signal performance and compliance concerns. Fourthly, using a GFCI outlet provides protection against ground faults and some surge events. Fifthly, regular inspections are essential to detect damage. Sixthly, consulting with a qualified electrician is recommended for complex grounding and surge protection decisions. Always prioritize safety and adhere to the manufacturer's instructions. By following these guidelines, it's possible to install and operate the cellular amplifier safely and effectively.